Okay, guys. Let me solve this. So, by the way, um, with these last couple AMC problems, don't expect me to get any of them right. I'm just doing it to finish the set. Then I'm gonna go back to the normal my counties problems where I'm gonna get like a lot more correct. So on these last few, I'm just hoping to learn, not really get them correct, but a cyclic quadrilateral ABCD has lengths BC equals CD equals 3 and DA equals 5 with the angle of CDA equals 120. What is the length of the diagonal of the shorter diagonal of ABCD? Okay, so if we have A here, no, let's start with B. No, let's start with C. C here. So C here and here. Let's say this is B. This equals 3, this equals 3, so these are equal. Then DA equals 5, so DA is longer, it equals 5. And then CDA equals 120. What is the length of the shorter diagonal? Wait, so if CDA is equal to 120, then if we make another circle, it's going to look more like, if this is D, it's going to look more like that. If this is D. So then that would make this A, so then this is longer, and then this is C. So then this has to be B, since this has to be the same as this, and then we're back down here. So the length of the shorter diagonal, I don't like how it says, like, it should say the shortest, because there's so many diagonals, I think. If we just draw these lines. Yeah, okay. So if we have, let's draw this gray. If we have this diagonal. Oh, wait, what am I talking about? There are only two diagonals. So it's asking for the length of this diagonal. Well, it's clearly, since it's the longest side of this triangle, it's going to be greater than 6. So it's greater than 6. Sorry, is it greater than 6? It's less than 6. Which all of these are, so it doesn't eliminate anything. How do we get this? So we have an isosceles triangle. Yep. Anyways, guys, so if this is 3 and this is 3, then we can't really tell anything about this. We need to use the fact that it's a cyclic quadrilateral, or that this is 120. I don't really know how to use that though. Well, huh. We know that this is the mid. No, do we know that this is the midpoint? We know that this is not the midpoint of this. But we have an angle here, which maybe can help us. With this angle here, can we do with this angle? Hmm. dA is equal to 5. If we have this thing right here with 120 degrees, 3, 5, and then we have this, I believe we can use the law of sines and cosines to find that out. So we know that if we call this alpha, beta, and gamma, I don't know. We call that A, B, and C. We know that 5 over sine A is equal to 3 over sine C is equal to, let's call this y. Y over sine of 120. Sine of 120 we know is 120 would be right here. Oh no, it would be up here. It'd be it's 30 degrees after 90 degrees. So that give us root 3 over 2. I feel like there's some rule with the diagonals of a cyclic quadrilateral, but I don't really know what it is. And if we have these lengths, can we use these lengths to get this final length, and then maybe we can use that to get the length of this diagonal? I don't really know. I don't really know how we get that. I feel like we could somehow figure out a way to get this longer diagonal, and then with that, get to this diagonal. But I wouldn't really know how to do that. And also, if you look at 7, 7 appears nowhere in here. Maybe it's like 2 times this minus this. But like, how do they end up getting 7? I don't know. 2 times this minus that. Okay, maybe it's... I really couldn't tell you. I'm gonna look at the answer now. Why don't I make a guess just for the funs of it? This one would be... Okay, the diagram that they have is pretty accurate. So, or not pretty accurate. My diagram that I made is pretty accurate to the diagram they made. So CVA is equal to 60. How did they get that? Okay, by some property of cyclic quadrilateral, CVA is equal to 60. And they say let the longer diagonal equal u. Then they apply the law of cosines. And they say let that equal that. By Ptolemy's theorem, it's probably something I should know. So they use the side lengths to get something using Ptolemy's theorem. Then how'd they get over 7? They got... Oh, because AC was 7? Yeah. Anyways, so I didn't get that right, of course. What was the actual answer? So I know, I guess, was correct or not. The actual answer was 39 over 7. Um, but I should probably... I'm gonna write down some more Ptolemy's theorem so I can always remember that. But, thank you guys for watching. I'll see you guys tomorrow. Bye.